All right, so today's notes are on absolute value inequalities. Our content objective is to write and solve absolute value inequalities, and our language objective is to use the correct terminology to describe and explain those. So we're going to jump in with the first type of absolute value inequality we're going to work with. If x, the absolute value of x is less than 5. So what this means, if the absolute value of x is less than 5, it means that the distance from 0 on the number line must be less than 5. The same could be said if it was less than or equal to, it would just be less than or equal to 5. So what that means is if I have a number line, 0 in the middle, 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5, that's positive 5. I know that this is 0. So the farthest it could go this way is to -5, and the farthest it can go in the negative direction is -5. The farthest it can go in the positive direction is -5. So it means that my answer has to be somewhere in this range where the distance to 0 to 5. So if I end up with a absolute value is less than, that means the distance has to be less than that number or that distance. So it is going to be bounded, which means it's going to be an and inequality. So my solution set is going to end up being an and inequality because I know my distance is going to be bounded because it has to be less than a certain amount. So we're going to do an example of that one first together. So our example asks, what is the solution of the absolute value of 2x minus 1 is less than 5? This time I want to make sure that we graph the solution. So let's do that. The first thing we're going to do, step 1, we're going to write an and inequality, we isolate the absolute value, or check to make sure it's isolated. That one is already done for us. There's no numbers being multiplied, added, subtracted, divided around that inequality sign, so the absolute value is already isolated. So I'm going to go on to step 2 and write an and inequality with the positive and negative values as bounds. What I mean by values, since I know the distance is going to be less than 5, I know my lower bound is going to be -5, as we talked about up here. And then I have 2x minus 1, so that the distance from 0 has to be between -5 and 5. So I know that when I solve this out, it could be either greater than -5 or less than 5. When I solve it out with values instead of distances, it's between -5 and 5. So I've set up my and inequality or my sandwich inequality, however we want to call this. And now I'm going to solve it out or solve out this problem. So the way I'm going to do that is solve for x by doing the inverse operation. Just like we normally would do. Or in this case, because there are 3 sections, there's this side, the middle, and the far right, we're going to do the inverse operation to all parts. So what that looks like, if I'm trying to get x by itself, I know I need to move 1 first. So I'm going to add 1 to all 3 parts here. So then I end up with -4. The 1's cancel here, so I have 2x and 6. So I added 1 to all 3 parts. Now I'm going to keep going and I'm going to divide by 2 on every part. So to get x alone, I need to divide by 2. Divide by 2, divide by 2. -4 divided by -2 is -2. Those 2's cancel there, so I have x and 3. So my solution inequality is going to be x is greater than -2, less than 3, and less than 3. So my last step, step 4, is to graph the solution So when I do that, I know it's going to be bounded because it's an and inequality. So I have -2, 1, 2, 3. So I have an open circle because neither of these are equal to, and it's bounded, so I'm going to connect those dots, and that is my answer. All right, so that's our situation when we have absolute value inequalities with less than. We isolate the absolute value, we set up our and inequality, solve it out, graph it. Or is going to be just like our or inequality. So I'm going to flip the page and talk about that. While I'm flipping this page, if you can send me a quick email and let me know that you're listening to these notes so I know you're doing what I need you to do to understand the stuff. So send me a quick email, kleary@k12.somerville.ma.us, but send me a quick email, let me know you're listening. Now I'm going to continue on. So in this case, we're going to use the same example, 5, but this time our absolute value or our distance from 0 needs to be greater than 5. So in this situation, the distance from 0 must be greater than 5. So again, let's draw a number line and see what that might look like. We have 0 in the middle, 1, 2, 3, 4, 5, and do an extra 6. 1, 2, 3, 4, 5, 6. So here, since the distance has to be greater than 5, I know my circles are going to be at -5 and 5, but they're going to go away from, because the distance needs to be more. So we need the distance to be more than 5, so our answers need to be farther away than those starting points. So when we have a greater than with an absolute value inequality, it means that our distance needs to be greater than. We're going to end up with an or our arrows are going to be in the opposite direction. That's going to be an or inequality. So when we have and, or when we have less than, it's and, greater than, it's or. So it's going to be just like our or inequalities, but we're going to do an example together regardless. I want us to solve the absolute value of 2x plus 4 is greater than or equal to 6 and graph the solution. So again, I always want us to write this so it's really drilled into your mind. You always isolate the absolute value first. In this problem, that's already done. There's no multiplication, no adding, no division, or surrounding that absolute value. So I can just start right in with step 2, which is going to be set up 2 inequalities. So since it's not an and, we can't set it up as one long string. We have to set it up as 2. One is going to be greater than or equal to the positive value. And the other is going to be one that is less than or equal to the negative value. So just like we set up 2 when we're solving these equations, absolute value equations, we set up 2 equations, one positive, one negative. Same thing we're going to do here. The only thing is this time when we set them up, we know they have to be going opposite directions. So we have to set up our inequalities switched. So I'm going to say, so my first one, 2x plus 4 is greater than or equal to 6. So I have that one to start. My other one's going to be 2x plus 4 is less than or equal to -6. So that way my answer would be less than -6 or more than positive 6. But you can think of this a couple of different ways. It's going to be less than -6 because it's going away from that, or it has to be less than that farther in distance, or from 0, or just like when we multiply or divide by negative, we have to flip the direction of the inequality. Same thing here. You made it negative, you have to flip the inequality. A few different ways to think about it. The rest of it is pretty much what we've been doing before. We're going to solve both inequalities. So I'm going to start by subtracting 4 from both sides. I get 2x is greater than or equal to 2. I divide both sides by 2, and I get x is greater than or equal to 1. That's my first part. And then the other one, I'm going to do the same step. So I subtract 4 from both sides. I get 2x less than or equal to -10. Divide both sides by 2. X is less than or equal to -5. So those are my 2 solutions. Last thing I'm going to do is graph solution set, or the solution set. So make my number line. I'll put 0 over here, so I do 1, 2, 1, 2, 3, 4, 5, -6. So I know I'm going to have a closed circle, since it has the equals to at 1, and then it goes in the positive direction. Again, a closed circle at -5 goes in the negative direction. And we are done. Make sure you write down any questions, comments, or concerns you have on this so we can go over it together in class.